In this example, we'll be finding arc length. A circle has a radius of 18.20 centimeters. Find the length of the arc intercepted by a central angle having the measure 3 pi over 8 radians. Just to get an idea of what we're doing here, let's draw a diagram. We have a circle with a radius of 18.20. We have an angle, which is, I'm going to draw an arrow into here. It's 3 pi over 8 radians. What we're interested in is finding the length of S, the arc that's intercepted by this central angle of 3 pi over 8. Well, we use the formula S equals r theta, where r is the radius, theta is the central angle. So we have S equals 18.20 times 3 pi over 8, and that would be in centimeters. Substituting all of that into the calculator, we find that S, and it will be an approximation, is approximately equal to 21.44 centimeters. Let's take a look at another arc length problem. A circle has radius 18.20 centimeters. Find the length of the arc intercepted by a central angle having the measure 144 degrees. Well, remember that we have a formula that allows us to find the length of the arc when the angle is measured in radians. So the first thing we want to do is to convert 144 degrees into radians. We do that by multiplying by pi over 180. That would give us a result of 4 pi over 5 radians. Now we can use our formula, S equals r times theta. We substitute 18.20 for r. We substitute 4 pi over 5, and that's going to be centimeters when we multiply them together. Substituting all of that into the calculator, we find that it's approximately equal to 45.74 centimeters. In this example, we'll be using latitude to find the distance between two cities. Latitude gives the measure of a central angle with vertex at the Earth's center whose initial side goes through the equator and whose terminal side goes through the given location. Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, while that of Los Angeles is 34 degrees north. The north in 34 degrees north means north of the equator. Earth's radius is 6,400 kilometers. Find the north-south distance between the two cities. I've drawn what depicts the information given to us. Here's the center of the Earth, so let's mark that C. And we know that the radius of the Earth, 6,400 kilometers at the equator. We're told that LA is 34 degrees north. That's here. We're told that Reno is 40 degrees north. What we're interested in finding, and obviously this is not to scale, but we're interested in finding this distance from Los Angeles to Reno, and we're told that it's almost directly north. The way that I've drawn it so that it could be see the difference, it doesn't look like that, but that's what we're assuming from the information they gave us. So now, let me put kilometers here so we remember that it's kilometers. So what we want to do then is calculate the angle inside here. And the angle inside there would be equal to 40 degrees minus 34 degrees, or in other words, 6 degrees. So the central angle for this arc length S is 6 degrees. And now we can use the formula. I'm sorry, first we should convert 6 degrees to radians and then use the formula. So we have 6 degrees is multiplied by pi over 180 degrees. And that tells us it's equal to pi over 30 radians. Now we use the formula that tells us S is equal to R times theta. R in this case is the 6,400 kilometers, which will multiply times pi over 30 radians, and our answer will be in kilometers. So S is approximately equal to 670 kilometers. So the distance from Los Angeles to Reno is approximately 670 kilometers. In this example, we'll be finding an arc length. A rope is being wound around a drum with radius 0.8725 feet, as the figure shows. How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? We're going to use the formula S equals R times theta. R is equal to the 0.8725. Theta has to be in radians, so we would multiply 39.72 degrees times pi divided by 180 degrees. Substituting all of that into a calculator, we'll find that S is approximately equal to 0.6049 feet. And that means that the rope will be wound around the drum approximately 0.6049 feet. In this example, we'll be finding the measure of an angle using the arc length formula. Two gears are adjusted so that the smaller gear drives the larger one, as shown in the figure. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? What you need to know is that the distance that this smaller gear rotates, so the arc length, will have to be equal to the arc length that the larger gear rotates through. So therefore, we're going to use the arc length formula, S equals R theta, and first we'll calculate the length of the arc that this smaller gear will rotate through that angle of 225 degrees. So S will be equal to R, 2.5, times theta. Theta needs to be in radians, and therefore we'll multiply 225 degrees times pi over 180, converting this degree measurement to radians. When we simplify this, we'll find that S is equal to 25 over 8, and the unit of measurement is centimeters. Now what we'll do is use this information to help us determine the angle through which the larger gear rotates. So let me bring in a clean sheet so we can work on that. We will still use the formula S equals R theta. And remember, this is what we just calculated, the arc length of the smaller gear. Well, now, for the larger gear, what we have is S would be equal to R, which is 4.8 centimeters, times theta. And this theta is what we want to find. Remember, I said that the arc length of the larger gear has to equal the arc length of the smaller gear, and therefore we substitute 25 pi over 8 in for S. So 25 pi over 8 is equal to 4.8 theta. Now what we'll do is divide both sides by 4.8. When you do that, it actually simplifies to 125 pi over 192. Now that's theta in radians, but we're really interested in converting it back to degree measure. So we would multiply 125 pi divided by 192 times 180 divided by pi. And when we multiply and divide everything out, this will be approximately equal to 117 degrees. So what that means is the larger gear rotates through an angle equal to 117 degrees. A center pivot irrigation system provides water to a sector-shaped field with the measures shown. Find the area of the field. What we can see here is we have an angle of 15 degrees and we have a length here of 321 meters. So to find the area of this sector, we'll use the formula, but the formula requires that the angle be measured in radians. So we begin by converting 15 degrees to radians. So 15 degrees would be equal to 15 times pi divided by 180, and that converts it to radians, which is equal to pi divided by 12. The formula for area of a sector is that the area equals 1/2 r squared times theta, the angle of the sector, r, the radius. So the radius is 321 and theta is pi over 12. The area is equal to 1/2 times 321 squared times pi divided by 12. Evaluate all of this on a calculator and you'll find that the area is approximately equal to 13,500 square meters.